Okay, using our properties chart that you need to start becoming familiar with, because you're not going to have it on a test or a quiz. You will have a properties like word bank, but of course the chart won't be there to tell you what they are. We are going to go through some examples and try to figure out what property is being used. So in example 1 here, we have to first figure out what is changed, all right? And so if I compare the two sides, what I see that's different is the 4 plus x and the x plus 4. And what I notice is that the order has changed. And so I have to remember which property goes with order, and I know that that is the commutative property, and you can abbreviate COMM, but commutative has 2. It could be addition or multiplication, and so we have to think about, okay, what changed? And that was x plus 4, so that's commutative of addition. And you can abbreviate addition ADD. Okay? Looking at the second example. I have 3 times 4i, and then I have 3 times 4 times I. So what actually changed was the grouping inside parentheses. So the property that goes with grouping is associative. Now, you need to give a few extra letters here for associative. 3 is not appropriate. The first 3 letters are not appropriate. And then we have to decide, is it of addition or of multiplication? And when I look at the problem, everything is being added. So we would say that this is of multiplication. Okay? And you can abbreviate that. All right, then I look at number 3, and I try to see what's different from one side to the other. It doesn't matter which side it's on. If you look at the right, the 3 was outside parentheses, and if you distribute it, you actually get the left. So this is the distributive property. Again, you can abbreviate. Okay, that's supposed to be a D. All right, in number 4, looking carefully, what is different? Well, if you look inside the parentheses, those are exactly the same. The piece that's different is the placement or order of the square root of 4. Okay? So again, we're looking at order, which means commutative. But how is the square root of 4 connected? Well, that would be of multiplication. Multiplication. Okay? And the last one, in this little section, I see a bunch of addition. I see some parentheses. If I look inside the parentheses, that did change. So, so we grouped. We changed grouping, and so that is associative, but this time everything was connected with addition. So this is associative of, addition. All right, moving down. All right, I have another way for you to do it. Now I'm giving you a problem, and it doesn't mean you're going to solve it. It just means you're going to tell me what's different from one line to the next. So the first line is given, and then I look at the second line, and I try to figure out how they got that. Well, it appears that the 3 has been distributed. So that is the first property, distributive property. Okay? In the second one, it had a 3 plus a 2i, and then it still had a 3 plus 2i, but the order was different. Nothing changed, but the order was different, and so that's commutative, and everything was connected by addition. And then in the last one, all they did was put parentheses around that, and that means they grouped, and so that is associative, but it is still of addition. Okay? In the second box, we're starting with a whole new problem. And it kind of looks like we've got, we have a binomial times a binomial. And then in the next step, it took the x from the binomial and put it in front. And then the 2 from the first binomial and put it in front of the x minus 3 as well. So what it did was it actually changed the order of how the original was written. The original said x plus 2 times x minus 3. And then it split up the x and the 2 in a different order. So that is commutative of multiplication. Okay? Then, if you look in the next step, all of a sudden we have an x squared, which means we must have distributed the x onto the first parentheses and the 2 onto the second parentheses. So that's the distributive property. And then the last step, we actually combined like terms. And anytime you combine like terms or simplify something, that property is called substitution. Substitution. Okay? Moving down, let's look at some true and false. Addition is associative. Well, we have to remember what the word associative means, and that means that we can regroup things, and yes, you can regroup things with addition. Okay? Now, number 10 says subtraction is associative. Well, not exactly. It depends on where the minus is and where you put the parentheses, and so if it's not true all the time, we have to say that it's false. All right, now 11 and 12 are talking about order. All right, well, number 11 says in dividing order matters. Well, think about it. If I have 1 over 2, is that the same thing as 2 over 1? No. So order definitely matters when you're dividing. Oh, sorry. So that's what I meant. It does matter when you're dividing. So that means true. Sorry. And then in multiplication, does the order matter? Well, if I said 2 over 3 times 4 over 7, I would get the exact same answer if I did 4 over 7 times 2 times 3, or 2 over 3. So that means the order does not matter in multiplication. Okay? Next page. All right, this time it says for the given value, find the multiplicative inverse and the additive inverse. Well, remember the multiplicative inverse is the reciprocal, but the additive inverse is the opposite sign. Okay? So for number 13, let's do all the multiplicative inverses first. And again, those are reciprocals. So the reciprocal of negative 8 is negative 1 over 8. The reciprocal of 2 is 1 over 2. However, the reciprocal of 0 does not exist. There isn't one. So you can either cross it out or even better, just say there's none. And then the reciprocal of 1 over 2 is 2 over 1 or just 2. All right, now we're going to look at the additive inverses, and again, those are the opposite signs. So if I have negative 8, the additive inverse is positive 8. If I have positive 2, the additive inverse is negative 2. Now, is there an opposite sign for 0? No, because 0 is not positive or negative. So here's another one that's none. It doesn't have one. And then for 1/2, the additive inverse is negative 1/2. All right, the next set of questions is a little different because you have to decide if the statement is always true, sometimes true, or never true. Okay? So for 17, it says the opposite of a number. Now that does mean sign. the opposite sign of a number is negative. Well, that's true sometimes, but what if the number was already negative? Then the opposite would be positive. So this one is sometimes true. Okay? The additive identity is positive. Well, the additive identity means what number can you add to anything and the original number stays the same? Well, the additive identity is 0. So the question is 0 positive? And that is not true. Okay? So that is never true. 0 is not positive or negative. So when you get to number 19, it says 0 is positive. Again, that is never true. And then in number 20, the set of whole numbers is closed under division. Closed means if you start with, in this case, a whole number, and then you divide, closed means you will always get another whole number. Well, I can think of a ton of examples, but let's take the whole number 2 and the whole number 3. When I divide them, do I get another whole number? No, I get the fraction 2 over 3 or the decimal 0.6 repeated. So this is not true all the time. Well, is it true sometimes? Okay. Well, what if I took the whole number 2 and divided by the whole number 1? Would I still get a whole number? Yes. And so this one is sometimes true. Sometimes true. Okay? All right, still using the properties. This time it is an equation that has been solved for you, and you have to figure out what property has been used. Okay? Well, you always have to be given one step, the very first thing. All right, now let's see what's different from the first to the second. Okay, well, I see a -4 that was not there before. But it's added to both sides. Anytime you do something to both sides, it is a property of equality. And in this case, it is the addition property of equality. And those abbreviations are okay. Now, in the next step, it appears that they put like terms together and simplified. So remember, anytime you combine like terms or simplify, that's the substitution property. Okay? And then in the next step, all right, you have to be careful with this one, because if you just looked at the left, 2 and 1/2 are reciprocals or inverses of each other. But because they multiplied by 1/2 on both sides, remember, anytime you do something on both sides, that's a property of equality. This one is the multiplication property of equality, because they multiplied on both sides. And the last step, again, it looks like they actually did the multiplication and the simplifying, and so that would be substitution. All right, then I started you with a whole new problem in number 22. Well, it appears that the 2 has been distributed to give me the second line, and that is a property, distribution property. Okay? Now, look closely. I see a -10 that's extra on both sides. It's on both sides, so that's a property of equality. And what has been done? It's a subtracting 10, so that's the subtraction property of equality. Well, then it looks like terms have been put together, and we've simplified, so that's substitution. And then, just like in the last one, we've multiplied by the same number on both sides. So that's the multiplication property of equality. And then it looks like we've simplified again. So that is substitution. Okay? Just a few more. All right. See if I can fit two on the same page here. Not quite. All right. Now the cool thing is a lot of these properties work with i's. All right. And remember we said i's were imaginary numbers, but it's still the same properties. Okay? So if I take the given and I look carefully at the next step, it looks like I added the same number on both sides. So that's the additive property of equality. Even though it was negative, we added the negative. Then it looks like I simplified, so that would be substitution. Then the next step, there's an extra number on both sides, and so it was added, so that's the addition property of equality. And then we simplified again. So that's substitution. Then I have the same number on both sides thrown in there, but this time they're connected by multiplication. So that's the multiplicative property of equality. And then it looks like I simplified again. So substitution. So anytime you're actually solving, there's going to be a lot of substitution. All right, next box. All right, starting with the given, it appears that the parentheses have disappeared, and that would only take place if I distributed. Now, you have to be careful here, because if you look, there's nothing new from step 2 to step 3. There's nothing added in. The only thing that's different is that I actually switched the 10 and the negative 2x. So I changed the order, so that's commutative of addition. Then I added the 2 up, 5x, or subtracted 5x minus 2x, and simplified, so that's substitution. All right, looking at the next step, now all of a sudden I do have an extra piece on both sides, and it is joined by subtraction. So that's the subtraction property of equality. And then it appears that I have simplified, so that's substitution again. And all of a sudden I have a minus 10 on both sides. So again, that's subtraction, and anytime you do something on both sides, that's a property of equality. And anytime you simplify, that is substitution. All right, one more box. Okay, in number 25, we're started off with a fraction. And it says to multiply both sides by 4. Since it's the same number on both sides, and it's connected by multiplication, that's the multiplicative property of equality. Then it appears that the 4's canceled, and I actually put the 4 and the 7 together on the other side. So that's a substitution. That's a simplifying. Substitution. Can't spell. Okay. Now all of a sudden there's a minus 3i on both sides. So that's a subtraction property of equality. And then we simplify. So there's your substitution again. All right, well I have something new. This time I've divided by 5 on both sides. Well, since I did the same thing on both sides, but I divided, that's the division property of equality. And of course, once you actually divide and you simplify, that is substitution again. All right. Hopefully you will be able to do some of these on your own.